Hey everyone, welcome. Today, we're going to dive into something that is, no joke, one of the most powerful tools in any C programmer's toolkit, the array. Once you really get this concept, you'll unlock a completely new way to handle data and solve some seriously complex problems. So let's get right into it.
So let's start with a problem. Imagine this. You're writing a program, and you need to keep track of test scores for a class of 100 students. How would you do it? Are you going to create 100 different variables? I mean, score 1, score 2, score 3. Ugh, what a nightmare to manage. There's got to be a better way, right?
Well, of course there is. And the answer, the really elegant solution in C, is the array. You can think of an array as just a way to group a bunch of related items, all of the exact same type, that's key, into one single, organized block of memory. One name for the whole group. Simple.
This is a great way to picture it. Just think of it like a row of connected boxes, or maybe little storage lockers. They all share one name. In this case, it's C, but every single box has its own unique position number. This is what lets you grab any specific value you need, whenever you need it.
All right, so that's the big picture. A C array is your best friend for managing tons of similar data in a really efficient way. It's a bunch of variables, all of the same type, all living under one single name.
Okay, so we get what an array is, but how do we actually, use one in our code? Well, the first step is telling the compiler you want one. We call this declaring the array. And then we need a way to get to each of those individual boxes.
And luckily, the syntax is pretty simple. Here, int is just us saying, hey, we're storing integers. C is the name we're giving our little collection, and that number in the square brackets, the 12, that's the crucial part. It tells the compiler, go find me exactly 12 spots in memory, all right next to each other.
Okay, stop. Before we do anything else, you have to burn this next rule into your brain. It is probably the most important thing to know about C arrays. Counting starts at 0, not 1. Always 0.
So let's break that down. If we have that 12-element array C, the very first box, the first element, is C0. And if you think about it, since we started at 0, that means the 12th and very last item has to be at position 11, right? Which we get to with C11. You have to remember this. It'll save you a lot of headaches.
So that number we keep putting in the brackets, that's called an index, or sometimes a subscript. And here's what makes this so incredibly powerful. The index doesn't have to be a plain old number. It can be a variable. It can even be a calculation like A plus B. This is what lets arrays do some really dynamic and amazing things in our programs.
All right, so we've declared our array. It's like we've built a bookshelf, but all the shelves are empty. So how do we actually put stuff on those shelves? That's what we call initialization. One of the most common ways to fill up an array, especially a big one, is to use a loop. Take this for loop here. It just marches right through each index, 0, 1, 2, 3, 4, and at each stop, it neatly places a 0 into that spot in the array n. It's a perfect way to give your array a nice, clean start.
And what happens when we run it? Boom! Our program prints out the contents of the array, and just like we wanted, every single element is now a 0. The loop worked perfectly.
Okay, loops are great. But what if you know exactly what values you want in the array right from the start? Well, C gives us this awesome shortcut called an initializer list. You just declare the array, and right there, using curly braces, you just list out all the values you want. Super easy. And if you look at the output, you can see it works like a charm. Our array n gets created and instantly loaded up with all those numbers, 32, 27, 64, and the rest. Talk about efficient. Now, these initializer lists have a couple of really cool tricks up their sleeve. If you give it fewer values than the array can hold, C will automatically fill in all the rest with zeros. This means you can do a neat trick. Int an array of size 10 equal to 0. That one line is a lightning-fast way to set an entire array to all zeros. And get this, if you leave the size out of the square brackets altogether, the compiler is smart enough to just count how many items you listed and make the array the perfect size. No more, no less.
Okay, we've got the basics down. Creating, accessing, and filling up arrays. But where do they really shine? Let's check out a couple of real-world examples to see these arrays in action.
So check this out. It's a program to analyze a student poll. We've got one array, responses, that's just holding all the raw answers, every student's rating from 1 to 10. Then we have a second array called frequency, and our job is to figure out how many times each rating 1 through 10 shows up.
And this is where it gets really clever. The code just walks through every single response. And when it sees a response, let's say a student rated it a 7, it uses that number 7 as an index for our frequency array and just bumps up the count at that spot. And the final result, this beautiful, clean summary table. It's an unbelievably elegant way to tally up data.
But arrays aren't just for crunching numbers behind the scenes. They can actually help us see our data. This piece of code has an array full of numbers, and the plan is to loop through it and print a simple text-based bar chart, a histogram.
And would you look at that? For every element in the array, the program printed that many asterisks. So since the first element has a value of 19, you get a row of 19 stars. It's a really simple but surprisingly powerful way to get a feel for the shape of your data, and it's all driven by a simple array.
All right, let's shift gears to a really important concept in C. So far, we've been talking about arrays of numbers. But what about text? Words and sentences? Turns out C has a very special relationship between arrays and text, or what we call strings. And here's the big reveal. In C, there's actually no such thing as a string data type. A string is nothing more than an array of characters. That's it. So when you write a line of code like this, you're not making some magic string thing. You are literally just creating an array of characters, and the compiler is just helping you fill it in.
So let's pull back the curtain and see what the compiler's actually doing. When your compiler sees the word first in double quotes, it secretly turns it into this, an array with the characters F, I, R, S, T. But hang on a second. What's that weird /0 at the end?
Aha, that is the secret sauce. That's called the null terminator. Every time you create a string like that, C quietly tacks on the special invisible character at the very end. It's basically a stop sign. When a function like printf is printing your string, it goes character by character, F, I, R, and it just keeps going until it hits that null terminator. That's its signal to stop. That's how it knows the string is over.
So think about what we've seen. Arrays can organize huge lists of numbers. They can summarize data in a flash. They can even help us create visualizations, and they're the absolute foundation of how we work with text in C. They really are a fundamental building block. So the only real question is, now that you know how they work, what cool problems are you going to solve with them?